All right, in this video, we're going to be working some more multiple choice no calculator for AP Calculus, and I'm going to be working through I'm pretty sure that this is the international practice exam for 2008 for Cal BC. And so they're going to start us off with a quotient rule problem. Okay, that's really nice because we know that the derivative of top divided by bottom is going to be bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So they all have 2x plus 3 squared. Okay, that's not really helping me eliminate anything. So what I need is to simplify the numerator. I'm going to say that's going to be 6x plus 9 minus, when I distribute in the 2, I'll have a 6x minus 4. Okay, so I should have 6x minus 6x, and 9 minus negative 4 is going to be positive 13. So that's going to be up here. That's going to be answer choice D. Okay, if you have the quotient rule wrong, you would get A, right? If you were doing top times the derivative of the bottom minus bottom times the derivative of the top, which of course I don't recommend because that's not the quotient rule. Okay, just got to use the quotient rule properly here. So number 2, a particle moves along the x-axis so that at any time t greater than or equal to 0, its velocity is given by v of t as sine of 2t. If the position of the particle at time t equals 2 is x equals 4, what's the position at time t equals 0? Okay, well, this is just going to be a position. Oh no, I'm wheeling over somebody's bubble sheet. So position at time 0 is going to equal position at time pi over 2 plus the integral from pi over 2 to 0, right? F of b is f of a plus the integral from a to b, regardless if a is bigger or smaller than b, of x prime is velocity. So that's sine of 2t dt. Okay. The x of pi over 2 is 4. So I'm going to say 4 plus, and then I'm going to take an antiderivative for sine. That's going to be negative cosine. Now I'm going to divide by that 2 to prepare for the chain rule. And that will be negative half cosine of 2t. And I'm going to let t run from pi over 2 to 0. And that'll be like me plugging in. Okay. Well, cosine of 2 times 0, that's going to be cosine of 0, that's 1. Okay, wait, so cosine of 0 is 1 minus cosine of pi is going to be negative 1. Okay. So it's going to be 2 times negative half is negative 1, 4 minus 1, that's going to be... All right, what's the value of negative 2/3? The nth power as n runs from 0 to infinity. Well, this is a geometric series. The common ratio is negative 2/3, which is between negative 1 and 1, so I know that this thing's going to converge. I'm going to know that the first term is negative 2/3 to the 0, and that's 1. And then I will be saying, all right, the sum is equal, provided that the ratio is between negative 1 and 1, is going to be the first term, which we determined was 1, times 1 over 1 minus that common ratio. Alright, so this is equal to 1 over 5/3, and that's why I wanted to choose that answer choice. For values of h very close to 0. That's interesting. I don't know if I've ever noticed them use that terminology before, very close. It's not very mathematical, but which of the following functions best approximates tangent of x plus h minus tangent of x divided by h? Okay, so this is like basically, okay, if h goes very close to 0, okay, we're taking the limit as h approaches 0, tangent x plus h minus tangent x all divided by h. Okay, well this limit here, this is the derivative of tangent of x with respect to x, and we know that. Hopefully you don't have to write this down. If you recognize, okay, they're talking about the derivative of tangent. I know the derivative of tangent. It's secant squared. Okay. Arc length. Okay, this is y equals f of x. Okay, so I need to use, that arc length formula in x, x1 to x2, square root of 1 plus dy dx squared integrated with respect to x. Okay, dy dx is going to be 4x to the third. So when I square that, I'm going to be having the integral from 1 to 5 with the square root of 1 plus, okay, when I square 4, I get 16, and when I square x to the 3, I get x to the 6. E to the x divided by 1 plus e to the x, that's okay. There's not anything algebraic I can do because the addition down there, that's going to be really troublesome. What I can do instead is I can do a u du, because this is u prime divided by u. Okay, the derivative of the bottom is appearing on the top. So I'm going to let u equal 1 plus e to the x, so that du equals 0 plus e to the x dx. And then I'm going to be saying, all right, I've got exactly e to the x dx and then 1 over u. And that's going to be the log of the absolute value of u plus c. And then from there, okay, well, we know what u is. U is 1 plus e to the x. So, okay, here it is. Here's choice B. And they don't have the absolute values on there because if you think about it, 1 plus e to the x is always going to be a positive number for any x. All right, now we're going to do some Euler's method. And we just did that recently, and we're pretty strong with that. So, all right, I'm going to be starting at 1, negative 2, 2 steps to go to 1.4. Okay. So x equals 1. Maybe this is x equals 1.4, so my first step is going to take me to x equals 1.2. And my second step will take me the rest of the way. Okay, my first tangent line, I've got a point. I've got a slope, x minus y minus 1. 1 minus negative 2 is 3, minus 1 is 2. Okay, the equation is y plus 2 equals 2 times x minus 1. I'm going to plug in my first step, x equals 1.2. Y would be negative 2 plus 2 times 0.2. And let's see, that would be negative 2 plus 0.4 would be negative 1.6. And I'll write down a second tangent line. Point. Slope is dy dx is x minus y, so 2.8 minus 1 is 1.8. Okay, so my equation is going to be y minus negative 1.6 is equal to 1.8 times x minus 1.2. And then I'll plug in my second step. Okay, 1.4 minus 1.2 is 0.2. Always good to point out that if there are 2 steps of equal size, that should be the same number both times, which it is. And all right, this is going to be 0.36, so that's negative 1.6 plus 0.36, which is going to be negative 1.24. Okay, trapezoidal approximation. I'm glad this showed up because I know that a lot of us struggled with this on the previous practice test, right? We had a hard time when that came up on the free response because we didn't really know the formula for the area of a trapezoid. Okay? So I'm just going to remind you, we always are looking at least in a calculus class, we're looking at trapezoids that have parallel heights, and the bottom base is the one that's like kind of make them right angle. And then maybe the rest of it goes like that. So, okay. So we're going to, in this case, we're going to average H1 and H2, and then we're going to multiply by B. That's how we're going to find the area. Okay. Area equals base times average the heights. That's what we're going to do repeatedly over here. But we're not going to draw a little diagram or anything, because that doesn't really work. That doesn't work for getting us credit and free response. It certainly works. I mean, depends on what you mean by works, though. To me, works means get you credit on the AP exam. So, all right, I'm going to average the bases and multiply by the width. Or average the heights and multiply by the width. Plus, all right, I'm going to average the heights. Multiply by the width. Okay, and then 8 plus 12. I probably should have just mentally averaged those, but that's okay. We'll be multiplying by a width of 2 one more time. All right, the trapezoidal approximation for the integral is 52. What's the value of k? All right, so this equals 52. And then I'm going to go in here and, okay, luckily for me, all these 2's are canceling off. That's nice of them. So I've got 4 plus k plus 8 plus 8 plus 12. That's equal to 52. So that's 12 and 20 is 32. 52 minus 32 would be 20. And so k is going to be 10. That was an interesting one, but I'm glad that the trapezoid thing came up, right? Because that was something that we needed to work on. F is twice different. Oh, you can't even really read that. F is twice differentiable, and the graph of F has no points of inflection. All right. First of all, I'm seeing that the second derivative is negative while the first derivative is negative, and there's no points of inflection, so the second derivative is going to be negative, so the first derivative is always going to be decreasing, and so it is possible that the first derivative is positive, but it's going to be to the left of x equals 6. Okay, to the right of x equals 6, f prime is always going to be negative. Okay, which means that f of 7 has to be less than 3. Okay, so I've got 2 of these gone. Okay, but I actually know that it's probably got to be less than 2.5. All right, so if I'm at 6, 3, and I've got a slope of -0.5, let's say in the most basic scenario, we've got that slope of -0.5 here. Well, then at x equals 7, y would be 2.5, right? Because if the slope was -0.5, we would expect when we bumped up x by 1, y would go down by 0.5. Okay? But I also know that I don't have a straight line here. I've got a curve that is decreasing and concave down. Okay, so since it's concave down, it has got to be below this tangent line, basically. And that's the reason this is the only one it could be. Okay. That one was an interesting problem. I don't remember having worked that one before. I know of problems that are like this one, but I'm not sure about that exact problem. Okay, we've worked this one recently. I think I put this one in the unit test for the Taylor series. All right, so, all right, it looks kind of like cosine, but it's not alternating, and that there's not really any way we're going to be able to deal with that. What we'll do instead is be like, okay, well, I think it's going to be this one. I think it's going to be e to the x plus e to the negative x. Okay, so we know that e to the x is 1 plus x squared over 2 factorial. Maybe I'll go up to 4. Yeah, I'm seeing it is this one. Okay, when I plug in negative x for x right here with parentheses around it, well, I'm going to square it and it's going to become positive. Same thing over here. That'll be a negative because I'm taking negative x to the third power. Yeah, and if we add those together, I'm going to get 2 plus 0 plus 2x squared over 2 factorial plus 0 plus 2x to the 4 over 4 factorial. So if I added these together, I'd have twice as much as the series they're talking about. So the series they're talking about must be half of this. Okay. the sides and diagonal of the rectangle are strictly increasing with time. At the instant when x is 4 and y is 3, z is going to be 5. And dx dt equals dz dt, and dy dt is proportional to dz dt. Okay, well, what do we know about this right triangle for sure? That's going to be x squared plus y squared equals z squared. Okay, and if all of these things are changing with respect to time, well then I'm going to have to take the derivative of this equation implicitly with respect to t. So I'll have 2x dx dt, 2y dy dt is equal to 2z dz dt. Okay. And then I think at this point I need to start subbing known values in, right? Yeah, x is 4. Okay. Dx dt is equal to dz dt. 2y is going to be 6. Dy dt is equal to k times dz dt. Okay. If x is 4 and y is 3, then z is going to be 5. And so that will be 10 dz dt. I think I'm going to divide both sides of this equation by dz dt, so I'll lose it here and there and there. And so I'll have 8 plus 6k equals 10. That means that 6k is equal to 2, and k is going to be 2 divided by 6. If f prime of x is 2 over x, and f of the square root of e is 5, then what's going to happen with f of regular e? Oh, okay, I think, wait, well, f of b is f of a plus the integral of f prime. Okay, nothing else we can do here. So okay, so that's going to be equal to 5, and then I'm going to add in the integral from the square root of e up to e of 2 over x dx. Okay, so 5 plus 2 log of the absolute value of x as x was to run from the square root of e to all of e. So that's going to be 5 plus 2 times, all right, the log of e is 1, minus the log of the square root of e is a half. 5 plus 2 times a half is 5 plus 1, and that's going to be 6. For time t greater than 0, we've got parametric equations for the position of the particle. What's the acceleration vector of the particle at time t equals 1? All right, since I'm seeing different values of y double prime, you know, the y component of acceleration, I'm just going to only work with that. So I'm going to say, all right, y equals 3t plus 1 to the negative first power. Y prime is going to be negative of 3t plus 1 to the negative 2 multiplied by 3 to account for the chain rule. And y double prime, which is what I'm going to be needing, right? Because I know that the velocity vector, I've still got enough room to write that. That's going to be x prime and y prime. So the acceleration vector is going to be x double prime and y double prime. All right, y double prime is looking like positive 6 times 3t plus 1 to the negative 3. Then times another 3 for the chain rule. And when t equals 1, I'm going to have 6 times 3 plus 1 is 4 to the negative 3 times an extra 3. Let me think. 4 to the third is going to be 64. And so I'm going to have 18 over 64. That's really annoying. Now, I'm not allowed to use a calculator to simplify 18 over 64, so what I'm going to do is I'm just going to divide in half. 9 over 32. There we go. Only one answer choice had 9 over 32. All right. 8 over x squared minus 4 integrated. Oh, yeah, we're going to need to do partial fractions because I'm seeing second degree in the denominator. It's factorable. That's automatic partial fractions, pretty much. So I'm going to say, all right, over here, 8 over x plus 2 and x minus 2, I'm going to be able to rewrite that as a over x plus 2 and b over x minus 2. And then I'm going to multiply both sides by x plus 2 and x minus 2. And that'll be 8 equals a times x minus 2 and b times x plus 2. Okay. What was I thinking here? Okay, yeah, then now we're going to let x be 2 and then negative 2. Okay, 8 will equal 4b. Meaning b equals 2. And then when x is equal to negative 2, it's going to be 8 equals negative 4 times a, which means that a is going to be negative 2. Okay, so now I'm taking the integral of negative 2 over the x plus 2 plus positive 2 over the x minus 2 dx. And I should be able to solve it from here, right? Yeah, I think it will be... Oh, this is that thing. Okay, because this is a 2008 international practice exam, you're going to see where they're going to assume you know the log properties and know how to do that. I'm pretty sure that if you were to get this problem today, it would just be these things added together just like that. They would not combine them with the log property. But if this one's the negative one, the x plus 2 needs to go in the denominator, so it's going to be answer choice C. Okay, which of the following could be a solution to the differential equation with the initial condition y of 0 equals 1? Okay, the solution is what we can sketch in here and, follow the lay of the land. Okay, I'm just following the general pattern. Okay, and notice how the closer I get to the y-axis, the flatter it gets. Okay, so I'm not going to be able to actually cross the y-axis. So that means that this one is out, and that doesn't look like the graph of e to the x. E to the x looks like that. That's just not it. Okay, 1 over 1 minus x, or not 1 over 1 minus x squared. The square root of 1 minus x squared, that is part of a circle. Okay, and it looks like that. But specifically, I would say, if you think about what happens with a circle right there and right there, we're not seeing horizontal slopes at the x-axis, which is what we're seeing down here. So that one's going to be out as well. Okay, y equals cosine x. Well, we know what that graph looks like also. It kind of confidently passes through the x-axis. So can't be that one, it's got to be this one. And while I don't think that 1 over 1 plus x squared is maybe a function that you just have to know its graph, it's a pretty useful function. It's the type of function that's always positive. I've seen this graph come up various places. Might be good to know about, but it's not like the most important thing. But that's... You can either find it by knowing what the graph of 1 over 1 plus x squared looks like, or you can use process of elimination. And either way, it's provided you know what they mean by a solution to the differential equation. Right? They don't mean slope field. So f prime is the absolute value of x minus 2, which could be the graph of y equals f of x. All right, before you go in there and let yourself get confused at all, think about an absolute value. That's always positive. Okay, f prime is always positive. Okay, so I'm down to these two right here. Okay, let's see. Okay, but at x equals 2, f prime of 2 needs to equal 0, right? I need that to happen. And f prime is not defined here because f is discontinuous. So it's going to be this one. Okay. I think that, if f prime is always defined, then f is always differentiable, means f is always continuous, and so it can't be that one. I think that's a good reason. Right, the radius of convergence for the power series is equal to 1. What's the interval of convergence? Okay, so that's where we're just going to plug in. Okay, it's centered at x equals 3. The radius is 1, so it's going to go up to 4 and back to 2. So I'm going to try x equals 4. I'll be taking the sum from 1 to infinity. If 4 minus 3 is 1 to the 2n, any power of 1 is 1 over n. This is the harmonic series. We know it diverges. Okay, so definitely does not converge at x equals 4. I have a feeling that at x equals 2, it's going to be the alternating harmonic series. I think it's going to be this one right here, E, but we don't know that quite yet. Oh, no, it's not going to be the alternating harmonic series. It's going to be D. Maybe you see why that's the case. But when I do 2 minus 3, I've got negative 1 to the 2n over n. Okay. Negative 1 to the 2n is like negative 1 squared to the n, and negative 1 squared is positive 1. Okay, so this is going to be harmonic again. And so I'm going to choose answer choice D. And it was really that 2 right there that caused the issues. F of x is arc cosine of x squared. Thank goodness. I was waiting for one of the obscure trig derivatives to show up, right? I don't think they showed up on that last exam. And I think I need to remind you about these. All right, so we know that the derivative of, okay, maybe you're just like, you've got it memorized, but you don't really know what to do. The derivative with respect to x of inverse cosine of x is equal to negative 1 over the square root of 1 minus x squared. Okay? So when I go to take the derivative of arc cosine of x squared, all right, well, that would be negative 1 over the square root of 1 minus something squared. And so where I would have put x, I'm going to put x squared, and then I'm going to multiply by 2x to account for the chain rule. So really, I think I'm looking for a negative 2x in a numerator. Yeah, here it is. And there's that one. Don't forget those obscure trig derivatives. Let me throw out some other ones there for you. All right, so there you go. I put up a little reference sheet for you. Derivatives of tangent, secant, cosecant, cotangent, arcsine, arccosine, arctangent. We need to know all of those. There's also a couple of others that I want to tell you about. I think we all agree about the derivative of e to the x with respect to x. That one's easy to remember. It's its own derivative. But also, I'm going to just take a second to remind you that the derivative of like 2 to the x is 2 to the x with a factor of the log 2 attached. Okay, so that's another one of the derivative rules we need to know. And it's not just 2, it'd be just like a to the x is a to the x times log of a. Even if a is e, fits with that. Okay, but I was just going to remind you of some obscure, I guess not all trig, but derivative rules that we need to know. So slope of the line tangent to the curve at the point 2, 0. All right, we're going to take the derivative implicitly. Plus 0 equals 1x minus 2 cosine of y multiplied by dy dx for the chain rule. And then we're going to plug in x equals 2 and y equals 0, and then just solve for dy dx. I might call it y prime for simplicity. X is equal to 2, y is equal to 0. Add it over here. 3y prime equals 2. That's telling me y prime is equal to 2/3. They're more generous than me. I would have definitely made one of the distractor answer choices 3/2 because I'm definitely prone to that algebra error sometimes. All right, next we've got an old-fashioned which of these converges type problem. And this one, I don't know. I know I used it either on the retest or on the regular test. Maybe I used it on both of them. This is one I use pretty frequently. 1 over the square root of n, that's a p-series with p equals 1/2, so that's going to diverge. Okay, 3 to the n over n factorial. Well, factorial is so heavy on bottom, I know it's going to converge. I'm going to come back to that and prove to you that it's going to converge. This is a geometric series with a ratio that's e divided by pi. E is less than pi, so this ratio is going to be less than 1 in absolute value. So this absolute value of r less than 1, that's going to be converging. And then this one, it's going to be 2 and 3 only. But I'll convince you of this in case you're like, I don't know if I believe you. 3 to the n is growing a whole lot faster than n factorial at first. But not for long. What we're going to do is we're going to do the ratio test. We're going to compute the limit as n approaches infinity of 3 to the n plus 1 divided by n plus 1 factorial divided by the terms of the original. So it would be n factorial up here and 3 to the n of the denominator. Which is going to leave me okay with 1 power of 3. And then n factorial over n plus 1 factorial, well, that's 1 over n plus 1. Okay, and that limit as n goes to infinity, that's going to be 0, which is less than 1, so this one converges, and that's why it's 2 and 3 only. Thank you.
I'm going to go to the restroom before I start the other thing.
Okay, great, yeah. I'll have it ready for you. And then this one, oh, okay, I know this problem, and this one does not come with any sort of, like, warning buzzer or flashing lights or anything, but this one you do need to be careful about. Like it's the fractional power, because this one's got a critical point that is not a 0 of the derivative. Okay, that's what I'll say. So f prime is going to be equal to 2/3 of 9 is 6, x to the negative 1/3 plus 3. Okay. And I think that I might just write that. Actually, no, I'm just going to leave it right the way it is. And, okay, f prime fails to exist when x equals 0. Is this running out of ink? It shouldn't be. It's got a lot left. F prime fails to exist when x equals 0. Okay. F prime is equal to 0 when 6x to the negative 1/3 plus 3 is equal to 0. And then I'm going to subtract 3 and divide by 6. And so, wait, what am I thinking? Negative 3 over 6, so that's negative 1/2. And I don't know why I'm having such a hard time with this. I'm going to take negative 1/2 to the negative 1/3, or the negative 3 power. Yeah, because negative 1/3 times negative 3 would be positive 1. And then I'm going to say, all right, well, that's flipping it and cubing it. So that's going to be 2 times 2 times 2 is equal to 8, but it'll be negative because it's the third power. All right, so I've got my two critical points, x equals 0 and negative 8. All right, and I'm going to just check to see where f prime goes from negative to positive, right? Okay, well, when x is really negative, I think that this is going to be definitely negative. Because if I have, like, negative 1,000, well, the 1 over... Right, not allowed to use a calculator. So let's think about this. Oh, I know what we're supposed to do. We're supposed to choose, like, negative 27 or something. Yeah, let's choose negative 27. Okay, when I plug in f prime of negative 27 is 6 over the cubed root of negative 27 plus 3. Okay, so that's going to be the cubed root of negative 27 is negative 3. So I've got 6 divided by negative 3 is negative 2 plus 3 is positive. Then somewhere here, like maybe, I don't know, negative 1. And f prime of -1. Okay, well, that's going to be -6 plus 3 is going to be -3. And so that would be negative. And then when x is positive, well, a positive number to the -1/3 power is going to be positive, and multiply by 6, still positive, add 3, even more positive. So I've got a relative minimum here at x equals 0. And maybe I switched the, I don't know, I guess it was just that it had a critical point that was not 0 with the derivative. All right, anyway, let's keep moving. The function f has a continuous derivative. If the integral of f from 0 to 4 is 8, what's the integral of x, f prime? Okay, x times f prime of x dx, that's going to be u dv. Okay, we're going to need to use integration by parts because I'm not going to be able to use u du, and it's a product, is what I'm saying. So I'm going to let u equal x. I'm going to let dv equal f prime of x dx, which would give me du equals dx. And v equals f of x. Then I'm going to remember that the integral of u dv is equal to u times v minus the integral of v du. And, okay, that's what I've got. So it's going to be u times v, x f of x, minus the integral from 0 to 4 of v du f of x dx. Okay, well, they already told us that. That's going to be 8. So this is going to be equal to 4f of 4 minus 0f of 0. And then that integral, they told us, is 8. Okay, so what is f of 4? Is -3. Okay, so 4 times -3 is -12. Minus 8 more, -20. Okay, slope of the tangent to a polar curve. That's troublesome. Okay, it'll be all right though. So I know that this is one that's going to, involve some product rule, right? So it's going to be y is r sine theta, which is okay, y prime, I'm going to use the product rule, derivative of this, leave the other one the same, then leave 2 theta the same, and take the derivative. Okay. I'm going to do the same thing for x. And that's going to be 2 theta cosine theta. And x prime is going to be equal to 2 sine theta minus 2 theta sine theta. I think I just did this problem, but I don't know. Maybe there was one very close to this on a different practice exam that we took. And, okay, anyway, we know that dy dx, which is the slope of the tangent line, that's going to be y prime over x prime. So y prime of pi divided by 2 divided by x prime of pi divided by 2. And that's going to be, all right, y prime with pi over 2 plugged in. Okay, up there, that's where sine is 1 and cosine is 0. So I'll have 2 times 1 plus something that has a 0 on it. Okay, so it'll be 2. Okay, 2 cosine is going to be 0, minus 2 theta is 2 times pi over 2. And then the sine of theta is positive 1. Okay, so this is 2 over negative pi, and there it is. Okay. Radius of a circle is increasing at a certain instant. The rate of increase in the area of the circle is numerically equal to twice the rate of increase of its circumference. Now, I know I've done this one recently. I feel like... Okay, I don't know where it was. It must have been on like one of the AB review quizzes that I was giving y'all or something, but I know I've worked this problem recently because I need a formula for area of a circle. That's pi radius squared. I need a formula for circumference. That's 2 pi radius. So I can take the derivative with respect to time. Okay. Now I'm going to substitute back over here, dA dt is 2 times dc dt. Okay, I'm going to divide by pi. I'm going to divide by dr dt, and I'm going to say 2r equals 4. So that would be r equals 2. All right. Oh, I hate this problem. Okay, not because it's hard or anything. It just doesn't really do anything for anyone. All right. Table above shows several Riemann sum approximations to the integral from 0 to 1 of 1 over x dx using right-hand endpoints of n subintervals of equal length. Which of the following statements best describes the limit of the Riemann sums as n approaches infinity, like as in the number of summands or number of rectangles that we're going to take? Okay, it's going to be, and I feel like they could have just asked you about this, like, hey, does it exist or does it not exist, you know? But I guess you're supposed to see that each time it just continues increasing. But it's integral from 0 to 1 of log, no, not log x, 1 over x. Okay, that's going to equal log x as x runs from 0 to 1, which is going to be the limit as x approaches 0 from the positive side of log of 1 minus log of x. That limit doesn't exist. Okay, it's going to come back 0 minus negative infinity, basically. And so that's going to be positive infinity, and so the limit of the Riemann sums doesn't exist because there's an infinite amount of area in there. Okay, but I think that's enough. That's all I really feel like saying about that. Coefficients of the power series satisfy a0 equals 5, and an is this number of an minus 1. Interesting. Okay, so what we're going to do is we're going to do the ratio test on this one. Okay, so pretty much, yeah. So we're going to be taking the limit as n approaches infinity of an plus 1 divided by an's absolute value. Okay. Well, if I go an plus 1 over an, or that's like the same as an divided by an minus 1, right? That the next one's on top and the previous one's on bottom. I could just divide that over there and say that's the limit as n approaches infinity of the absolute value of, in parentheses, 2n plus 1 over 3n minus 1. Okay. And I think... I think I may have oversimplified this a little bit. Because we also have x minus 2 to the n plus 1 divided by x minus 2 to the n. Oh, okay, so it's just going to be, it's going to have a power of x minus 2 over there. I did not oversimplify it. So I just have this extra power of x minus 2 first. And then I'm going to say, all right, as n approaches infinity, this is 2/3 of x minus 2. Okay. Of the absolute value of x minus 2 is less than 1. Well, I'm going to divide, or multiply by 3, divide by 2. Absolute value of x minus 2 is less than 3/2. That's the radius of convergence. Also, it's like the kind of the number in the denominator. You could say it's like 3/2 in the denominator from multiplying by 2/3. Okay, that one's weird. I don't remember that one, but I probably wouldn't use it in my class. This one, on the other hand, I use in my class regularly. Hopefully, you recognize these. Okay, the ones that I'm talking about. Otherwise, you're just really primed to get tricked again. So I know when I'm taking the derivative of a function to find my integral, I take that upper bound, I throw it in wherever I see the dummy variable in the integrand, and then I don't forget to multiply by the derivative of the upper bound to appease the chain rule. So it's going to be t squared minus t. But then we're going to have to multiply by 2 for the chain rule, so I feel like it's probably going to be that one. But then that's f prime of x, meaning that f prime of 2 is going to be 2x is 4, squared is 16, minus 4 times 2, that's 2 root 12. Okay. Yes, this one. I've seen this problem before. Sine of x plus 1 over x squared. Which of the following statements are true? All right. Horizontal asymptote, that's what happens as x goes to infinity. So as x goes to infinity or negative infinity, I get closer to taking the sine of 0 because this is a bigger on bottom fraction. So I think this is true. All right, so that means that then 2 just can't be true. And yeah, that would not. If this was cosine, then we'd have a horizontal asymptote at y equals 1. Now the vertical asymptote at x equals 0, this is the real thinker here. The thing of a vertical asymptote is division by 0. But, like in here, what's happening on the inside of the argument of sine, right, is this thing that as x approaches 0, this fraction's approaching infinity, right? Yeah, from both sides. And yeah, it's going to be positive over positive. Yeah, it's going to positive infinity. Okay, the inside, the thing I'm taking the sine of. But that just means that it's going to bunch up. It's like the sine of 1 over x, essentially. Is that all of those waves that would normally happen out here are going to instead get pivoted and get like wedged in here, and it's going to get really dense. But it's going to have like a discontinuity because of oscillation, but not a vertical asymptote. Also, for any real value of x, okay, like any number x that you could put in here between negative infinity and infinity, x plus 1 divided by x squared, I guess except for x equals 0, it's going to come back as a real number. Okay. And then when you do sine to that real number, whatever it is, when x is just not 0, well, the sign is stuck between negative 1 and 1. So I'm still not going to go outside of these kind of like bounds. And so a vertical asymptote is where we're going up to infinity. That's another reason why it's not answer choice 3. I'm concluding it's A. If you want more discussion on this, come and talk to me about it. Also, I might suggest, pulling out a graphing calculator and looking at the graph of something like sine of x plus 1 over x squared and seeing what it looks like. But that's going to be all for this video, I think.